Unit 4, Risk and Return, Lecture 3, 2 Asset Portfolio. So far, we've looked at the returns or expected returns and risk for a single asset. Now we're going to move on to the concept of a portfolio. We're going to start with a simple 2 asset portfolio, and we're going to look again at measures of expected return and risk. So when we look at a 2 asset portfolio, we have asset A and asset B, and we're going to have a weight on each asset. So we're going to decide how much we're going to invest in each asset, whether it's 50% for each of them or maybe 75% in one, 25% in the other. Those are the weights. Then each asset will have an expected return. And we will use all of this information to calculate the return or the expected return on our portfolio. I'm going to try and understand these concepts for a portfolio by means of an example. So you have the following probability distribution for stocks A and B. We're going to look at the state of the economy. And the economy only has 2 phases, expansion and recession. There's a 2/3 chance or probability of an expansion, 1/3 for a recession. And stock A behaves well during expansion, not so well during recession. Surprisingly, stock B performs quite badly during an expansion and very, very well during a recession. So maybe we're looking at necessities here. Anyway, we're now going to move on in the next slide to calculating the expected return. We start off now by looking at the components of the portfolio. So the 2 components of the portfolio are stock A and stock B. And we're going to start by calculating their expected returns during the different phases of the economy. So if we look at stock A, its expected return is 0.67 times 0.1 plus 0.33 times 0.06. So we expect stock A to generate a return of 8.67%. Looking at stock B, overall, it's going to produce a return of 12%. So now we're going to look at how a portfolio would perform if we combine A and B to create our portfolio. So in this instance, we've chosen to equally weight our portfolio. So we've put 50% in stock A and 50% in stock B. So when we calculate our expected return, half our return is going to come from stock A, half is going to come from stock B. And we end up with an expected return for our portfolio of 10.335%. Notice it's not as high as the return on stock B, but it's better than the return on stock A. So when you are constructing a portfolio, you really are looking at trying to get a decent return, but not taking too much risk. I talked in the previous slide about risk, not taking too much risk. So how do we know how much of risk we have in these assets and in the portfolio as a whole? So when we look at a portfolio, the variance and the standard deviation, which are our measures of risk, look at the variance of a portfolio of risky assets is the weighted sum, taking into account both the variance of the individual securities and the covariance between securities. And the standard deviation of the portfolio of risk securities is the square root of the variance. We've talked about that before. So what is covariance? We mentioned it in the definition of the variance. And it's a very, very important concept. Covariance is a measure of the degree to which returns on 2 risky assets move in relation to each other. A positive covariance means that assets' returns move together, while a negative covariance means that they move in the opposite direction to each other or inversely. And that is very, very important because when you're constructing a portfolio, if you combine 2 assets with a positive covariance, that means when one is performing badly, the other is also performing badly. And if one is performing well, the other is performing well. Now, it's okay if they're performing well, but it's not so good when they're performing badly. And that introduces the concept of diversification, which we will talk about a little bit later on. Now here we're going to look at the what some people call an ugly formula for calculating the variance of a portfolio. It actually relies on the weights of each of the assets in the portfolio, their variance, and their covariance. And I think, again, it's probably easier or make a little bit more sense if we use an example to explain it. We're using the same example that we had before, and we know that our expected return from the previous calculation is 10.335%. Now, instead of doing two separate calculations for the variance and the standard deviation of each asset, we're actually just going to calculate the standard deviation. And we know that the standard deviation is the square root of the variance. And we know that when we're calculating our variance, we look at the squared differences between the return and the mean, and we multiply that by the appropriate probability. And what we end up with is that the risk for stock A is 1.886%, its standard deviation, and for stock B it's 19.799%. You'll notice how much bigger the standard deviation for stock B is than for stock A, and you can see that in the variation of the returns. So during an expansion, stock B actually generates a negative 2% return, but it generates a 40% return in a recession. Whereas if you look at stock A, it generates a 10% return during an expansion and only a 6% return. So the deviation or the difference between those two is not that significant. And we can see that when we look at the standard deviation for stock A and stock B. Now we're going to calculate the covariance, and the formula looks at no longer the squared difference, but the difference of each return from its mean for stock A and stock B multiplied by the relevant probability for expansion and for recession. And what you'll see is that there's a negative covariance between these two assets. And it's actually quite obvious if you look at the returns from the information we were given in the table. So when stock A generates 10% return, actually stock B generates a negative 2% return in an expansion phase. And when stock B generates a positive 40% return, even though the return for stock A is positive, it's actually significantly smaller. So the covariance again substantiates the differences in the risks between these two assets and the fact that they move in opposite directions to each other. So from a diversification point of view, again, we'll talk about that in detail later, combining these two assets in a portfolio is actually very, very positive. We finally arrive now at the calculation of the risk for our two-asset portfolio, and that risk is measured by means of standard deviation. And for the purposes of the portfolio, we're actually going to calculate the variance first and then do the standard deviation calculation. Looking at the variance, it's a combination of the weights and the variances of each of the components, stock A and stock B, as well as the covariance between them, and we end up with a variance of 0.008022. Our standard deviation, which is the square root of that, ends up being just under 9%. What's really interesting about this is if we had constructed our portfolio entirely using stock A, we would only have a standard deviation of 1.9%. If we had constructed our portfolio exclusively using stock B, then we would have ended up with a standard deviation of just under 20%. Quite significant in the difference there. But by combining these two assets in a single portfolio, and because their covariance is negative, which means that their returns move in opposite directions, we've actually brought down the risk to just under 9%. So the average return is lower than 12%, which was stock B's return, but the risk is significantly lower than that for stock B, which is around 20%. And that is the benefit of diversification.